Okay, so let's take a look at this problem right here. So we have this geometry 2 side splitter theorem. If you look right here, we have GSRT4. We've actually done a couple SRT4s before, but this is actually a different one. If I was to look at my test, I think it's like SRTC4, but either way, but still. Now, from this one right here, we recall what we learned about mid-segment. We did mid-segment on page 11 of our notebook. Okay, mid-segment is created by connecting the midpoints of two sides of a triangle. In figure, right here, DE is the mid-segment. So this is the mid-segment here. So if we know that this is a mid-segment, then there's a whole bunch of things that I automatically know because of that. Now, if this is the mid-segment, what do I know about these two pieces? They are parallel. Very good. They're parallel. What else do I know about the sizes? DE is going to be half of AB. Okay? That is for the mid-segment. Okay? Parallel, and this is half of this. Okay? I need to know that. Now, for this right here, considering the following, segment IJ, which is right here in the middle, is not the mid-segment. Okay? We're already stating that. It's not the mid-segment. So I know that this is not going to be half. But it's still parallel to the third side of the triangle GH. So these two lines right here are parallel to each other. Okay? Now, the side splitter theorem, if a line is parallel to one side of a triangle, interconnects to the other two sides, then it divides the two sides proportionally. Now, the word proportionally also refers to like ratio or scale factor. We've already had a couple things like that. We're doing a comparison of two things. So what is the ratio of Fi? So what value do I have for Fi? Fi is 8. Very good. So I'm going to have 8 over, what is Ig? 2. So right there, so for those people following along, my 8 over 2 is going to reduce to what? 4 over 1, right? 4 over 1. So that's important. 4 over 1. Okay? What is the ratio of Fj to Jh? Fj is 12. Jh is 3. So, what does that reduce to? 4 over 1. So, we have 4 over 1 and 4 over 1. Are they the same? Yes. Let's go back right here. Then divides two sides proportionally. Here's my proportions, right? Okay, so there is my ratio for those. That's important. Notice about the two ratios. Okay, same ratios, so they are proportional. So they are proportional. Same ratios, so they are proportional. Now the converse, so converse actually works the formula backwards. So for this one, I had, I started off with them being parallel, and I'm working it through, I got their proportional. Their segments are proportional. So now right here, if a line divides two segments of a triangle proportionally, then it is parallel to the third side. So now we're going to try and prove that they are going to be parallel. So we don't have that they're parallel, but we're going to see if they're proportional. So to do their proportions, I would do, let's do this right here. So let's go like this. So what's that going to be? 2. So that's going to be my BD. 2. What's my other side? DA. There we go. So DA. So BD to DA. So what am I going to have? What's my values that I'm going to put in? 2 over 4, which reduces and gives me 1/2. Very good. 1/2. Now let's do the other side. The other side is over here, so it's going to be BE and EC. So BE to EC, which is going to give me 5 over 10, and that reduces to 1/2. Very good. Are they the same? So let's look at it. So if the two sides of the triangle are proportional, then they are parallel. Which ones are going to be parallel now? DE. So we're going to say that DE is parallel to AC. Does that make sense? Now, it also works out the other way. Okay, so now if I want to do part over whole, it works out the same thing. So part over whole, it would be, if I did it like 2 over, what's the whole thing? 2 over 6. Right? So what do we get there? 1/3. Okay, so part over whole. So what do I get if I do the same thing on the other one? 5 over 15. There's part over whole. So what do I get with 5 over 15? 1/3. Hey, is it the same as what I had? Yes. So they are the same here, but if you notice, their ratio is different. It's a different type of comparison, but they are going to be equal if I set it up the same way. We're going to have a problem like this, where I have to do part over whole for my practice today. All right, so let's take a look at doing some actual numbers on this. So for this one right here, if 3 parallel lines intersect 2 transversals, then the segments intercepted by the transversals are proportional. Okay, these are the arrows signifying that these 3 lines are parallel. Okay, so these lines are parallel. That's important. Now, how would I set up this side right here? How would I set up this side right here? I would start with 8 over what?
14.
Let's do this piece right here. I could do 8 over 14. That'll work. But I want to show you guys how to do the little pieces. So 8 over, what's this little piece right here supposed to be? 6. Where did I get 6 from? 14 minus 8 is going to leave me here with 6, right? Okay, so let's say right here. So 8 over 6 is equal to, so now we're going to use an equation out of this, because every single time I did this, all of them are always equal to each other, aren't they? So whatever I get right here, it's going to be equal to whatever I get over here, right? Yes. And since we're trying to solve for a missing piece, I need to set it up like that. So that's why I'm using 8 over 6. So I have that is going to be equal to, what's the other side? What's this side going to be?
14.
This side right here? So what piece goes with 8? It should be 12, right? Because 8 is over here on top, and therefore 12 has to be over here on top also, right? So these two go together, so it's going to be 12 over, what piece goes with the 6? The x, right? Did I confuse you guys all right there? Because it just slowed down all of a sudden. People were like answering stuff, and all of a sudden it was like, oh, what?
Because the x threw us off.
That x threw you off? Okay, you don't tell your x to go away. See what I did that?
No.
Anyway, okay, but still. Question over what I did, because all of a sudden everyone fell off at this point right here. So what is the problem with this one? Can someone tell me what? Ask a question for this one, because this is actually on your practice for today. Hayden. Are you okay with this one? Yes? Anyone else? Someone question.
How do you get 12 over x if you said the x goes with the 8?
Okay, yep. So if you notice, how do we set up this one right here? I put 8 over 6, right? Is 8 on top? Say yes.
Yes.
And 6 is on bottom, right? Okay, so now, since 8 is on top, what else has to be on top? The 12, that's where I get that from. So in this one, since 8's on top of my fraction over here, the 12 has to be on top of the fraction on the other side. That's where that one comes from. Does that make a little bit better sense? Okay, that's the reason why I said these ones go together. So this is the top of my fraction, bottom of my fraction, bottom of my fraction. Does that make a little bit more sense, you guys? Okay, so let's go ahead and try and solve this now. So 8 times x, so I'm going to use cross products. 8x equals 6 times 12? 72. So divide both sides by 8. X is 9. Okay. Now that's one way of doing it. I'm going to show you the other way. Let's do part over whole. Part over whole. So let's go back to this side right here. Part over whole. How would I set up this one? 8 over part over the whole. What's the whole thing?
Oh, 8 over
14, right? The whole thing on this side, because I'm only dealing with this side right here. So it'd be 8 over 14 because that's the whole, right? Okay. 8 over 14. And that's going to be equal to, what's my part?
12.
12, very good. Over, this is the part that it probably is going to get you on this one. But other ones later on, you'll be like, oh yeah, now I understand how to get this. What would I do to actually get the whole here? If I didn't have the 14 here, what would I do to get the whole?
It's blurry.
You would add them together, right?
It's blurry.
Oh, it's blurry. Oh, I'm sorry. My hand's in the way. Okay, sorry. Okay, right here. So for this one, if I didn't have the 14 here, what would I do with these two? Add them together, right? Okay. Now, do I have the whole thing here? Say no. So what am I going to do? Add them together. Just add them together. So it's going to be 12 plus x. There we go. Does that make more sense there? Okay, so now I have the 12 plus x. Now on this one here, when I do my cross products, I'm going to have to do a distribution here because it's going to be 8 times all of this. So 8 times all of this, so it's going to be that 8 times 12 is 96, right? I think so.
Yeah.
So 96. Now 8 times positive x plus 8x equals. Now let's multiply the other side. 12 times 14, I think it's 168. 168. So now we have an equation. I need to set up my thing and solve for x, right? So what am I going to do to both sides? I'm going to subtract 96 from both sides, right? So go ahead, subtract 96 from both sides. So 8x is equal to, what do I get there? I get 72 there. Divide both sides by 8. X is still 9. The reason why I wanted to do this and this, because you're going to have to solve problems using both means. Both ways you're going to have to solve them. So you're going to solve just using this. You're going to have some basic numbers like this. And then you're also going to have some complicated things where you have to set up, be like, okay, I'm going to add those together. Yes? No? Maybe? Hopefully. All right, so let's take a look at our practice over on page 14. So we're going to prove that these two triangles are going to be similar. We already know that AB is parallel to DE. mark it. So I'm marking that they're parallel.
Why did the camera keep focusing like that?
I don't know. It's new, and I think today's the first day I actually tried to use it. So I have that they're parallel. Now, if you go back in your notebook, there's only 3 ways that we have to try and prove that the triangles are similar. I have side, 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 similarity, angle, angle, similarity, and I have side, angle, side, similarity. So I have all of those there to actually try and prove that they're similar. So given this information, you're going to have to find a couple things. We're going to have to find them to figure out if they're going to be parallel. Or not parallel, I'm sorry, if they're going to be similar to each other. Because they're proving that ABC is similar to DEH. So ABC, so ABC, the whole thing, DEH, the little one. We're proving that they're similar to each other. All right, that's it. And I got a mess.